Hi Aryan, how are you doing?
Yeah, hi, I'm doing good. How are you?
Very good, very good. Aryan, it is amazing to see that even in grade 8, you can understand what grade 11 students find so difficult.
Thank you.
So today, what do you want to learn?
Yeah, so I wanna so in last class we kind of like started with the basics of like secant, cosecant, and cotangent. So
Hmm.
like I wanted to like explore even more and like master that because those are like important as well. So
Oh yeah, you
yeah,
mean to say you want to master sketching the graph of
yeah,
secant
that's the main thing. Yeah, sketching and like just identifying.
and identifying? Okay, so why don't you share your questions with me, and then we can work on those.
Yeah, about that, do you think you can share it instead? Because when I share it, like you won't have permission to
Yes,
annotate.
you have put them on the shared drive.
Yeah, it's there. It's called graphing secant and cosecant functions practice.
Okay, great. So let me just look into this. And so can you see the shade, right? These are your videos, right? So which one? Oh,
Yeah,
graphing
yeah, it's
secant.
that one, right
Okay.
there, right there. Yeah,
Oh my God. Okay. Oh, that's beautiful. So you already have a graph of secant right there. So that's pretty good. Your teacher has done a great job here, explaining how to sketch, and that's wonderful. Perfect. So this worksheet explains you how do you graph a secant function, right?
yeah.
Okay. So let me hold this. So, what part you don't really understand?
So it's not really like I don't understand. It's
Mhm.
more of like I get mixed up with like all the values and like it's just like too much at once to do.
Yeah, I agree with you. There are too many values in this small block. The whole graph is there. So let's like break it down and then do it. So I think that will be better for us, correct?
Yeah, that's fine.
So the function which you want to graph is y equals to secant 4x minus pi by 2, correct? So
Yeah.
secant is reciprocal of what?
Cosine. Yeah.
So basically, you are trying to sketch 1 over cos of 4x minus pi by 2. Correct?
Yeah.
That is what you're going to sketch. So it is a reciprocal of cosine function. Right? So let's think about it as a reciprocal
Yeah.
of cosine function. Now, in this cosine function, you also see that the cosine function actually has a phase shift, right?
Yeah. Yeah.
Yes. Can you tell me what is the phase shift of this cosine function?
Um, pi over 8 to the right.
Perfect. So you told me pi over 8. How did you get that answer? So let's rewrite this
Yeah.
as factoring out the k value 4, right? So what you
Yeah.
did was you factored out 4. Now this is most critical step in sketching, I will think, to begin with. So when you take out factor 4, then you get this pi over 8.
Yeah.
That's what you're saying. It is a phase shift of pi by 8 to the right, correct? So now you
Yeah.
have your function, correct? So basically what we have to do is, first part, we have to sketch cosine function, right? So let's say step one,
Yeah.
sketch cosine function, right? So let me just write cos theta, right? So whatever that theta is, which is 4x minus pi by 8, right? So I'm writing this as my theta, correct? So this is the
Yeah.
function which I'm going to sketch now. Now, let's review what we learned in sketching cosine and sine functions earlier. That will help us to bridge the understanding from where we are coming, right? So,
Yeah.
for cos theta, if you look at this particular function, which is, let me rewrite this as cos of 4x minus pi by 8, right? So, in this case,
Yeah.
what is the amplitude?
Just one.
Is 1. What is the max? What is the axis?
Uh,
We are not going up and
yeah.
down. We are
Yeah.
not
Zero.
talking
Yeah.
about the axis. is 0. And so we have the maximum value of 1 and the minimum value of -1, correct?
Yeah.
Now, so we know k is 4, and therefore time period is how much?
It's just 2 pi over 4, which is just pi over 2.
Pi over 2, right? So we know the time period. So the idea here is when you scale, when you make a scale, in that case, you have to have pi by 2 as the time period and divide this into 4 equal parts, right? So
Yeah.
in short, let me just give a rough sketch here. We learned how do we sketch it in two-step process, right?
Yeah.
So what we are going to do here is that basically we are going to have a frame here, and in this frame, we know that the maximum value is going to be 1 for us, and the minimum value is going to be
-1.
-1, correct?
Yeah.
And we have the time period t, which is pi by 2. So this is the time period t, correct?
Yeah.
We are going to divide this time period into 4 equal
Or
parts. 4 equal parts, right? So we do half of it and then further half of it.
into that. Yeah.
Basically, each is like t by 4, right?
Yeah. Yeah.
And then we have t by 8 here. Well, so total time period divided into 4 equal parts. I mean, I should not just let me.
No, it's fine.
Yeah, I wanted to write. Right. So let me write down here itself, because on this point, we know the time period is pi by 2.
Yeah.
Half of pi by 2 will be pi by 4, right?
5 by 4.
And half of pi by 4 will be pi by 8.
Over 8.
So it is
Yeah.
1 pi by 8, 2 pi by 8, 3 pi by 8. You see how I got all these numbers, correct? So I have these numbers here, right? We are looking at cosine function. So I'll sketch it in 2 steps, right? I will sketch it in 2 steps. Step 1, which I'll say now step 1a. Step 1a is without phase shift, correct? Cos starts with maximum, right? Since cos starts with maximum, I will write this as, I mean, let me use a color which is more prominent, right? So
Yeah.
this, it starts with maximum, goes to the axis, goes to the minimum, back to the axis, and right there. So this is your function, which is cos
Cos.
of 4x.
Yeah.
We have not considered the phase shift at present, correct? But we have just
Yeah.
designed the cos of 4x. Now we will consider the phase shift. So if I consider the phase shift, then that is to say, now we are looking into this particular function, which is this function.
Yeah.
Moving each point pi by 8 to the right, right?
Yeah.
So pi by 8, you can see, is one division here. So we are moving each point pi by 8 to the right. Is that clear to you?
Yeah, that's great.
Correct. And therefore, we get the cosine function starting from here, top, bottom, center, and back again. So I made only one side, just to explain you, right?
Yeah.
And the point which we have gone in is pi by 2 plus pi by 8, right? So that point where we are ending is basically pi by 2 plus
5 by 2 plus 5 by 8.
So if you take
So
common denominator
5.
of 8, so this is 4, right? 4 plus 1, 5, correct?
5 pi over 8.
Pi by 8. Is it clear? Or you
Yeah.
can count 1 pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8, and 5 pi by 8. Do you see that? So we're
Yeah.
talking about a cycle which is starting from pi by 8, ending at 5 pi by 8, giving you a time period of pi by 2, correct?
Yeah.
Perfect. So we get this cosine function. Now, obviously, this is a repeated function. I can go down here and I can go down here. That becomes my turning points. maximum being at 1, minimum being at -1. I got my cosine function, correct?
Yeah.
Reciprocal really means that the zeros will now be the vertical asymptotes, correct?
Yeah.
1, and the turning points will be the turning points, right? They are the invariant points.
Yeah.
Invariant points. They will be same in both the graphs, right? So the turning points, remember this, the turning points are common.
Are common.
Very important, right? Because
Yeah.
the inverse also goes through the same transformation. If you multiply cos with 2, the inverse is also getting multiplied by 2, right?
Yeah.
So if it becomes from 1, it becomes 2. There also you will have the local maximum minimum as 2 and -2. Is that okay?
Yeah. Yeah. Yeah.
And so we are now going to flip it. So when you flip it, you get your final function. So let me just flip it here, right there. So we get this now. Do you see that? Flipping it?
So you're flipping it from like the points that you have over
Yes.
there.
So we
Okay.
have the boundary of vertical asymptotes. We have
Yeah.
local maximum and minimum points, which are
Yeah.
common, the turning points. And from there, we are flipping it. And that is how you get your final graph.
Okay.
Yeah. Now let us see the solution, which is right there before us in this particular example to understand what we just did, right? Is that
Yeah.
all clear to you?
Yeah. Yeah. Yeah.
Very good. So let's begin with the very beginning. We have this question, y equals to secant 4x minus pi by 2. Take 4 common, then you exactly get the phase of pi by 8. Whenever you graph, you should definitely have pi by 8 in the graph so that you know by how much you have to move, right? In this case, pi
Yeah.
by 8. So secant is the reciprocal of cos 4x pi by 8, where the amplitude is 1 and the period is 2 pi by 4, which is pi by 2, right?
Yeah.
There is no vertical translation in this particular case, as you can see, but there is a phase shift of pi by 8 to the right, correct? The axis, so we have this particular x-axis. So what are we going to do? We first
Yeah.
said that we know that the period is pi by 2, which is right there, right?
Yeah.
So pi by 2 is written as 4 pi by 8. 4 pi by 8 is same as pi by 2, right? Now,
Yeah.
writing as 4 pi by 8 is actually very good because it helps you to count easily and add and subtract the numbers.
Exactly.
At the end. So I like
Yeah.
this idea of writing not as pi by 2, but as 4 pi by 8.
It's full power 8. Yeah.
So you
Because
have
it's even like given on the graph, so it's
yeah,
just easier for us to like vision it out.
perfect. So you have this graph. So actual cosine graph will be kind of like this, right? It will
Yeah.
be like this. And then what you do is, this is your actual graph. One way only I'm sketching at present, right?
Yeah. Yeah. Yeah.
I'm pressing one way. Then you apply the phase shift. So when you apply the phase shift, the point actually moves. And you can see that it moves to the points shown by the dotted line. You get the idea?
Yeah. Yeah.
So you get this dotted line, and that becomes the graph of the cosine function. So
Yeah.
now we have sketched the graph of the cosine function, which is now shown to you in the dotted line. Is that clear?
Yeah.
With the phase shift. Now
Yeah.
remember, very important point to remember is that the turning points are common.
Yeah.
So mark the turning points, all the turning points, they are common between the reciprocal function and the function.
Okay.
In between the cosine graph fits in. Do you see that?
Yeah. Yeah. Yeah.
And then we know that the zeros will get converted into vertical asymptotes. So the zeros are now the vertical asymptotes.
Yeah.
So those ones are drawn already. Perfect. So these are your vertical asymptotes with zeros. Do you see that?
Yeah.
And they are also the restriction on the secant function. Is it okay?
Yeah.
So all multiples of these after a phase shift, right? We have this 2 pi by 8 and then 4
Yeah.
pi by 8, right? So those
Yeah.
multiples are all, you can say, this is pi by 8 and pi by 2. And when you do 2 pi by 8, it is pi by 4, correct? So these
Yeah.
are your even multiples of pi by
You're even.
2,
Okay.
which are basically uh, vertical asymptotes in this particular case. Is that clear to you?
Yeah. Yeah. Yeah.
Perfect. And now when you flip, you get your secant graph. Is that clear to you?
Yes. Yeah.
So that is how you are going to sketch.
Okay.
Now, one more important thing is sometimes what we do is we give you the secant graph and we tell you find the equation of the graph shown.
Yeah. Yeah.
So
Yeah.
that is the reverse thing. And let us understand how do we do that? So let us say
Okay.
I gave you the secant graph. How will you prove that the equation of this particular function is uh, secant 4x minus pi by 2? How will you find the equation of the graph when I give you the secant graph? Tell me.
So basically, what I would just do if I was given this like a normal secant graph is I would just convert it into like the reciprocal,
Yes.
which is just one over the cosine of this like whatever else you have. And then what I would then do is I would then start to graph out the cosine graph, and then based off what I have like as the information, so like the maximum minimum values,
Yes.
the period, the phase shift, I would like make it like I would graph it out, and then knowing that a cosine is the reciprocal of secant, I would take the turning points that are like all common, and I would just flip it from there to have
Correct.
my secant graph.
Correct. So only thing you have to do is flip from the turning points to get your
Yeah,
cosine, and all the vertical asymptotes becomes the zeros.
yeah, yeah,
I should not say zeros because in this case it is a zero. Will be on the
yeah,
axis. Will be on the axis because this graph could have been shifted up or down. You get the idea.
yeah,
So it
yep.
will be on the axis. So that wherever the midpoint, the
The midpoint.
midline, the axis connects with the graph, vertical asymptotes, that is a critical point for you. Is that okay now?
Yeah,
How
yeah,
you really do it. So I hope it's absolutely clear, right?
yeah, it's clear.
So let me erase this and let's see the next example. Got it. So now, can you explain me how do we do this
Yeah,
graphing of this particular function?
yeah. So so we're given y is equal to 2 cosecant times 4x minus pi over 2.
Yeah.
So cosecant, the reciprocal for cosecant is this 1 over sine. So since we know that, we can just write it as y is equal to 2 times 1 over sine 4 times 4x minus pi over 2. Or yeah, you can just, yeah, you have to,
So basically factor out 4,
yeah,
which is a common factor. And now you know you have to draw a sine graph, right? And this sine graph has a phase shift of pi by 8. And we just know that time period is basically equals to 2 pi by 4, which is again pi by 2. Okay? And we have a
yeah,
phase shift of pi by 8 to the right. And we also know that the amplitude A is 2, but the axis is 0. And therefore, we have a maximum of plus 2 and we have minimum of minus 2.
minus 2.
Correct? So you will, as you said, you will draw minus 2 and plus 2 lines. Correct? You have the axis. Perfect. You have, now can you explain me how will you sketch the sine graph?
So we know that the phase shift is pi over 8.
Correct?
So we would shift our graph pi over 8 to the right,
Yes.
and then given our like period and our amplitude, we would like, so not amplitude, just given our period and all our other like properties, we would just like graph it out like a normal sine function.
Yes.
And then for all the turning points that we have, we would just flip it. We would just draw our cosecant graph from all the turning points.
Correct. So normally the sine graph would have been kind of like this, right?
Yeah.
And
Yeah.
this was from basically 0 to the time period t. In our case, it is 0 to time period was pi by 2, right?
5/2.
Which we are writing as 4 pi by 8. However, since there is a phase shift, we are adding to
Shifted.
this pi by 8, correct? Pi
Yeah.
by 8. And as soon as you add pi by 8, the graph coordinates actually are from, let me write down the value in a different color so it's very clear to you. And that will be pi by 8 to 4 plus 1, which is 5 pi by 8, right? So
Yeah.
2 points where the one cycle, the first cycle begins and ends is from pi by 8 to 5 pi. You get the idea, right? And
Yeah.
we know that the axis is still at 0, right? This is at 0. And the maximum being the amplitude, minimum being negative value of that. So we have 2 and minus 2. And these zeros are going to get converted to vertical asymptotes, right? So you have the vertical asymptotes right there
Yeah.
at these zeros, and you're going to flip the function to get the value, right? So you'll flip the sine graph to get cosecant. Is that clear? So
Yeah.
you flip it to get your function, which is cosecant. Clear? So that should be straightforward, right? Now you've understood.
Yeah. Yeah.
So that's perfect. Can you please read what is given here?
Yeah. So it says draw asymptotes where the sine curve crosses the center line.
Yes.
Mark the minimum and maximum points on the sine curve as points that are also on the graph of the cosecant curve.
Correct. So those are your invariant points. They do not change. They are common to both the graphs. That is the key to sketch the reciprocal of these functions. Is that clear?
Yeah.
Perfect. So let's look into the next question. So now
Yeah.
there are many questions for you. You have to quickly sketch these functions. Can you tell me the very first one? And then we'll skip to the fourth one, okay? Because the first one seems
Okay.
to be very
Yeah.
simple.
Yeah. Yeah.
But let's
Yeah.
do it for the sake of doing it and understanding, confirming our understanding. Is it okay?
Yeah. Yeah.
Okay. So
So
how will you do
basic. Yeah.
secant x by 2? Tell me.
Yeah. So basically, it's we don't have much values to work with, so we just turn the secant into like 1 over cosine of x over 2,
Yes.
and then we just graph the normal cosine function how it is,
Okay. You draft the cosine function normal. Okay. Then.
and then we have our period, which is 2 pi over just 1/2, which is equal to 4 pi. So then from our period, we would just like, so our period, yeah, that's where our period is. So we have all our like points, like our turning points as well, and there's no phase shift or anything else to work with. So we would just like graph our cosecant function from the turning points.
So yeah. So draw the vertical asymptotes at
Yeah,
the
yeah,
right.
yeah.
Mark the uh, uh,
Maximum and minimum, which is
and then go.
yeah,
That's clear. Absolutely clear, right? So that is how you get the y values for the given x value. So that is how you do it. In case there is a phase shift, you will start with minus pi by 4 here. So it is secant again cos. So your maximum will actually start from here and then you can go back, correct? So that is how you're going to do it. But now I would like you to sketch the question number 4, which is
yeah,
involving all the transformations. So let's look into this part. And now tell me, how will you sketch this particular function? Let me erase this. So
Yeah.
tell me, how will you sketch the graph of y equals to minus 2 secant pi x over 4 minus pi by 2?
Yeah. So it's basically the same approach
Yeah.
as we do for like normal, even if even if there's not like even there's not negative.
Yeah.
So just have -2 times 1 over cosine of pi over 4 times x minus pi over 4. If
So
I'm
you have to take pi over 4
yeah, pi
common.
over,
So
yeah,
you have to divide
pi
this
over,
by pi over 4. So what do you
yeah,
get? So I'll do it on this side just to show you.
yeah,
Because when you take pi over 4 common, you actually get here pi by 2
pi
times
by
4 over pi, right?
4 over pi.
4 over
That's
pi, correct?
so
So
it's
that is what
just
you get.
2.
So
Yeah,
minus 2,
minus
that's
2.
right on the top. And here I'm writing cos of pi by 4 and x minus pi and pi cancel, right? And then you have 2. Is it okay?
Yeah,
So that's what you get. And what is the time period for this?
yeah. This
Pi
is
by
2 pi over over 4, which
which is
is just
8.
8.
So you got a 8 as your time period, and phase shift is of 2 right. Is that it? P? Let me write P as 2 units right. Is that okay?
Yeah,
Maximum and minimum points are still 2 right, because there is no phase shift. There is no translation. Vertical translation is 0. And therefore, maximum is plus 2 and minimum is minus 2, right?
yeah,
So we can basically draw these boundaries, which are plus 2 and minus 2, correct? And we have the cosine function, which is shifted by pi by 2 units to the right, correct?
yeah,
So if it is shifted 2 units to the right, I will actually still prefer to sketch the cosine function with 5 points as going like this, correct? Is that okay?
yeah,
And then we know that this time period here is actually time period of 8. So this point is 8 for me, correct? Now when I shift it, this is 8, this is 4, and that is 2, right?
yeah,
And this is 6. Now I have to shift this graph by 2 units to the right.
mm,
That
right,
means my graph, all these points are coming here. This goes here, right? This goes there,
yeah,
and this goes there. So actual graph, and then this could have been here. So we have a point which comes here. So we have a graph which is kind of like. So that is how you'll sketch the graph of this is your cos function, correct? So we have cos
yeah,
of 2 times. Now it is, let me just redo it because it is minus 2, right?
yeah,
Since it is minus 2, we are going to flip the points, right? So it will go on the other side. So, or I could have done that also. Let me just do that. Just
yeah. It's whatever is like this makes it like whatever,
yeah,
however.
yeah.
Yeah,
Let me do both the things, right? So what I've shown here is the cos of 2 times cos of the function, which is pi
yeah,
by 6. Is it okay?
yeah,
And then I have done the phase shift also. Sorry, uh, pi x over 4. Wait. So I have pi by 4. Let me just. Because I included phase shift.
yeah,
X minus.
yeah,
I included phase shift. Now what I'm trying to do here is I'm actually sketching with the negative. Negative 2 cos of pi by 4. I could have done it last time also. All right. So then you flip it. So these points come here. That goes on the top. This the bottom. So it kind of flips. So you start with the minimum. Basically, the thing is that you start with the minimum, correct?
yeah, because it's a negative. Yeah,
Because negative.
yeah,
So That is how it is. Correct. So you have this negative, and now you have to sketch the reciprocal.
Yeah.
Sketch the reciprocal at each of these zeros.
Yeah. So if it just says negative, so aren't we just basically just reflecting over the x-axis?
Yes, yes. So reflect over x-axis. Perfect. And now what we are going to do is to sketch the real function which was required, which is the secant function. That is pi by 4 x minus
2.
right.
Yeah.
So for doing that, I'm marking my vertical asymptotes, right, at all these zeros, whichever I have, and then turning from the common point.
Common points.
Turning point. Is that clear to you?
Yeah.
And whatever I have is my final graph.
Yeah.
So in doing this, we are actually not calculating any points. You see that we did not make any table of values for the original function, for the image function, all those things. It was pretty fast.
It was, yeah, it's just, I was just using the table because like in school, we were like, my teacher, he just wanted us to use it. So I just started using it, but like, this is just much easier because you're just recognizing all the like,
Correct.
all the like, stuff that you have on in your equation that you can build off of, and then
Correct.
you just like graphing the like graph. So
Perfect. So that
yeah,
is how you actually sketch these functions. Is that clear to you? Now, this the next one. Let me clear the screen, which involves uh, translation. So that is important. We haven't considered this particular case. Now, can you tell me how will you sketch this particular function which involves translation?
this y is equal to 1 plus 2 secant x.
Yes.
Yeah.
Y is equal
So
to 2 secant. Yes. How will you do this?
so you have your, so basically you just do it as y is equal to 1/2 times cosine. Oh no, sorry. Yeah, y is equal to 2 times 1/cosine x plus 1.
Correct.
So and then you don't have a phase shift or anything like really to work with,
Yeah. Yeah.
but you, so basically you just graph your normal cosine function,
Yes.
except you shift it
So
one up.
correct. So axis is 1, right?
Yeah,
Amplitude is 2, correct? So
yeah.
what is the maximum value? 2 plus 1, 3, right? What is the minimum value? 2 minus 1.
Nice one.
The axis 1 minus 2, you can say. 1 minus 2 minus 1, correct? So, so from the axis, you have to go 2 up and 2 down to sketch your cosine function. You get the idea.
Yeah,
So now you can draw an axis which is at 1. So this is my axis, which is at 1. And from here, I draw my maximum, which is 2 units up and 2 units down.
yeah,
And then the cos function which I have is actually not translated left or right, and will
yeah,
happen at the same time period. Cos starts with, as you know, maximum, right? So we have a scale here. We'll divide this into 4 equal parts. Is it okay?
yeah,
So let us say these are the 4 equal parts. We are going to connect these points, right? So maximum, axis, minimum, axis, maximum. Do you see that?
yeah,
So what we have here is a cosine function.
yeah,
That is the cosine function. And we know we cannot label this. We are labeling this as 1, 1 plus 2 as 3. This is minus 1, correct?
yeah.
To draw the reciprocal of the function, we will draw the vertical asymptotes at the points where the graph crosses the axis.
Okay. crosses, yeah. Or intersects, anything works.
So the vertical asymptotes will be same as our orange line in this particular case, but I'm just redoing it for you. The ones which are actually crossing the axis, you see there. So we are only doing one wave. Of course, this is a periodic function. It gets repeated, right? So, okay, let me just do it on this side. Crossing the axis, mind it. Is it okay? And
Yeah.
now we have to sketch the final function, which you know is secant, which is y equal to 1 plus 2 secant x. Secant is reciprocal with invariant points at the turning points. Do you see that? These are invariant. So from here, we can flip.
Yeah.
Oh. And that becomes the graph of the given function. Is that clear to you?
Yeah.
You can
So
continue.
basically this all these like graphs just have to like deal with translations and transformations, like and using whatever information that's given.
Yes.
So like yeah.
So, and then what we did the vertical asymptotes as first point, and second, you turn, flip
Yeah.
from turning points.
Yeah.
So turning points, these are called invariant points. As they are common.
Yeah. Yeah.
Is that clear to you?
Yeah. Yeah.
Perfect, right? So that is how you have to incorporate the vertical translation, right? Which is the axis. Perfect.
Yeah.
So that's it about. So Aryan, do you understand this topic?
Yeah, I feel a lot better considering the fact that I didn't have a teacher to like tell me on like the past like couple of days because he was like out. And this really like clears everything up that like all the like questions and like all the like confusions that I have they're all cleared up now. So I feel
That's great. So I'll stop sharing that particular screen now. Can you
yeah.
summarize your today's learning on how do we graph reciprocal of primary trigonometric functions? That is secondary trigonometric transform functions. How do we graph them?
Yeah, so basically you first convert your cosecant or secant or like cotangent, all of that into like its reciprocal. And so let's like let's just say you have cosecant, you just like do it as like one over sine. So you're basically just graphing the first you're like first you're gonna graph the reciprocal function,
Yes.
and then after you graph the reciprocal function, you're gonna like you're gonna using your like your period, your phase shift, and like and your vertical shift, you're gonna like make your changes to your graph. So like and then after that you have after you fully do all the translations and transformations that you have, you find the turning points that so like that you have on your graph, and then from your turning points you would just flip it and just draw like another like graph, and then that's when you get your like function.
Perfect. So let me summarize it in exact steps, which
Yeah,
you
I
went.
did. Yeah.
You have explained each and every step, yes. But let me say it in a proper sequence, algorithm, which we can put as, right? So if you are given a trigonometric secondary ratio, which is normally a reciprocal of your primary trigonometric ratio in a general form, so that may involve phase shift,
Yeah.
amplitude change because of the vertical translations and reflections and stretches and compressions. Amplitude changes because of stretches and compressions. And
Yeah.
then what we have to do is first thing first, when you have an equation, if that k factor, which gives you the time period, is along with theta or the x, we have to factor this out. Once you factor the inside argument, then you get the correct phase shift. So first part is look at it very carefully. Does it need extra factoring so that you get the exact phase shift? So identify phase shift, first thing. Second,
Yeah.
identify the k value, which will give you the time period being 2 pi divided by k. So you get this time period. Now, this time period should be divided into four equal parts. To sketch sinusoidal function, it could be sine or cosine. Perfect. Four equal parts. When you draw a scale, also make a note of the phase shift. You should be in a position to do the phase shift accurately. In our examples, pi by 8 we fortunately got was also one-fourth of the time period, correct? So it was
Yeah.
easier for us to do it. Sometimes that could be something else, right? In that case, when you draw a scale, make a note of the minimal unit which should match with the phase shift. Perfect. Now, so first you draw the primary trigonometric ratio as such. Starting with the axis, draw the axis first,
Yeah.
and then the maximum and the minimum lines. So you have a frame, you have axis, maximum over this, and a minimum below it. So you know the graph is
Yeah.
between these two. Then draw the boundaries, signifying the phase shift starting and plus the time period, correct? So you have this boundary. Within this boundary, divide it into four equal parts. Once you do the four equal parts, then depending on the function, if it is minus cos, you have to start from the lowest point. If it is cos, start with the maximum. If it is sine, start from the axis. Go up, correct? So that is how you just connect those five key points and get your primary trigonometric ratios graph.
Okay. Yeah.
Once you've done that, then wherever the graph crosses the axis, those will be your vertical asymptotes on the reciprocal function.
Okay.
The turning points will be the common points from where the graph will turn. And you finally get your secondary or the graph of the function required. Is that clear to you?
Yeah.
Follow this algorithm, it will be very easy to sketch any graph.
Okay. Yeah. So
Yeah.
how would you like graph like the cotangent? Like, is it like just similar to like the cosecants and secants, or like does it require anything like different?
Tangent and cotangent is actually much simpler. So
Oh, because like
because, see, if you look at the tangent graph, let's say tan theta, right? Normal tangent graph. Then it is always increasing from minus pi by 2 to plus pi by 2. It has a period of pi, correct? So it is always increasing from minus pi by 2 to plus pi by 2. The reciprocal of this is cotangent, which will be like flipped. You see that?
yeah.
Instead of going like this, it will be like always decreasing kind of a thing. You get the idea. And it will shift. So the period for cotangent will be from 0 to pi. Very simple idea, so that it is absolutely clear for you and you can do any exercise on tangent and cotangent also, right? So what I will do here is I'll draw one wave which is for tan theta, right? So let's say we have
Yeah.
1 equals to this is tan. So the tan x graph will be kind of like this.
Yeah.
You see that, correct? Where these points are minus pi by 2, and that is pi by 2. This is definitely 0. On this, we have three critical points. The three critical points are at uh, pi by 4, right? Half of pi by 2, correct? And minus pi by 4, which have the values of 1 and minus 1, correct? So these are the three critical points for you. You can do any transformation of these 3 points to get the tan function. Perfect.
Yeah.
So let me just sketch another part of this because we
Okay.
might need part of the other cycle also. Let me just sketch it like this. Is it okay?
Yeah. Yeah, that's fine.
Yeah. So now let us see how do we sketch the graph of reciprocal of tan x, which will be cotangent x. Is that okay? So in that case, the zeros will become vertical asymptotes. You see that?
Yeah.
So these zeros will become vertical asymptotes. So this zero will be at pi, correct? Now, look at this point. One is invariant, right? One is not going to change. One will be invariant. Minus 1 will also be invariant because reciprocal of 1 is 1. Reciprocal of minus 1 is also 1. Correct? If the graph is approaching very large value, then it has to go through 0. 1 over infinitely large value will be 0. So those are going to be the zeros. And the cotangent function, therefore, will be kind of like this.
Yeah.
You get the idea.
Yeah.
Cotangent, that is always decreasing. You see, always decreasing.
Yeah.
Always decreasing, and it has already shifted by pi by 2 to the right. You get the idea, right? So the tangent function was always increasing.
Yeah. Yeah.
And the key points are, of course, I'll write it in different ink so that the key points are clear to you. 0, 0 in the center. And then we have pi by 4 with 1, right? Tan of pi by 4, and minus pi by 4 will be minus 1, correct? Those three key points. And then we have vertical asymptotes, right? At minus pi by 2 and pi by 2, correct? This is for tan function.
Yeah.
So all the vertical asymptotes become zeros. So vertical
Yeah.
asymptotes turn to 0. Increasing becomes decreasing. Do you see that kind of?
Yeah. Yeah.
As a whole, right?
It's basically like a reflection of the graph that I like
Yeah.
yeah.
Zeros becomes vertical asymptote. Zeros become vertical asymptote. So start with zeros of the tan, make them vertical asymptotes, right? And then put the vertical asymptotes as zeros, connect the points in decreasing manner, and you get your cotangent function.
Yeah.
So that is how you're going to do it. Is that clear to you?
Yeah.
So if tan function is transformed, doesn't matter. First transform it and then do the same thing.
Yeah.
So try some questions out. In case there is any difficulty, we can discuss it further, right? In the next class,
Okay.
we'll take it up in more details with more
Yeah.
examples. Okay.
Okay. Yeah.
So that's great. So do you have any other doubts to discuss?
Not really. Yeah, I think we covered it all.
We covered it all. That's perfect. So now I will also like you to work on finding the equation of the function from the given graph, right? So
Yeah.
do that exercise. So
Yeah, I'll do that.
yeah, sketch few graphs, right? So let's say you sketch a transformed secant function, then try to get its equation from the graph. Try to do the reversing. That is going to give you, more insight to understanding sketching trigonometric functions as a whole.
Okay. Yeah, I'll definitely check. I'll definitely do that whenever, and I'll because that's important because we've only like because if you just like stick to this graphing, you won't ever know how to identify, and like identification is going to be like a big one that's going to like come across. So I should definitely practice upon that.
Sure.
Yeah.
Okay, then. So let's end the class here today. And feel free to ask questions whenever. You can always send the email, and we'll always discuss it out.
Okay. Yeah.
Thank
Sure.
you, and all the best.
Yeah. Thank you very much.